Okay. So I'm gonna start recording here. Does anyone have any homework questions? Chapter 9.1 is due on Wednesday. Anyone have any homework questions? 9.1 is due on Wednesday. Only one section is due on this coming Wednesday. Anyone have any questions? Anyone? We still have one more questions left in 9.1 that we haven't gone through, which is number 2. We did number 1 on last week, Wednesday. And then we continue with number 2. And again, same thing with every Wednesday. If you want to do the Zoom on Wednesday, make sure you log into this Zoom link. You will get the Zoom class. Otherwise, I recommend you to come to class in school. So if you cannot make it to school, then make sure you have make sure you sign into the Zoom. We'll continue with number 2 in 9.1 here. All right. Anyone have any questions for me? Anyone have any questions? Anyone? So we're going to talk about 9.1. So this is a question 2. So this is question number 2 in 9.1. The claim statement is given us here that the seat belts are effective in reducing fatalities. This one is very important. So just because it's very similar to your finals look very similar to this. So we got a simple random sample of front seat occupants involved with car crash. Among 2,823 occupants not wearing seatbelts, 31 were killed. Among 7,765 occupants that wear seatbelts, 16 were killed. So you need to use a 0.05 significant level to test the claim that the seatbelts are actually effective in reducing fatalities. So as you guys remember, the last time that we did here, we always need to tell me which one is your population 1 and which one is your population 2. And usually, if you read this claim statement, the one that comes first is the first population. The one that comes the second population. When you do your online homework 9.1, they will tell you which one is the first population and which one is the second population. However, in your test or in your finals, in this case, I won't tell you which one is first and which one is second. So you have to tell me which one are we picking up for the first one and which one we're going to use for the second one. So this is very important. So anyone wants to, so this is between those who wear seatbelts and those who do not wear seatbelts. So anyone wants to tell me which one you need to declare as a population 1? Anyone? Population 1?
2823.
Is what? I'm sorry.
2823.
I know. They wear seatbelts or not wear seatbelts?
Not wear seatbelt.
Okay, so population 1, we are not wearing seatbelts. So this is very important. And then population 2 are those who wear seatbelts. Okay.
You don't want the numbers, you just want the...
No, we just need to declare it first.
Okay.
Okay, now we want the number, yes. So since you declare population 1 is those not wear seatbelts, what is your X1 and N1 in this case? Those who did not wear seatbelts. X1 is those who got killed, right? So how many got killed not wearing seatbelts in this case?
31.
Out of how many people did not wear seatbelts?
28, 23.
And then we do the X2 and YN2. That means these are those who wear seatbelts who got killed. So how many people got killed? Look in this example, those who wear seatbelts. There are 16, right? And out of 7,765. So these are those who do not wear seatbelts. Okay. Now, the first question A here is asking us to do our hypothesis testing because the question did ask us to test the claim. So means you have to perform the 7 steps, usually 6 steps now, hypothesis testing. So the first thing we're going to talk about here is your requirement. Okay, your requirements. So the first requirements, if you remember what is the first requirements that we have, is number 1 actually. We have requirements. So the first requirement says that you need to have simple random sample. So this is based on here. It has to be 2 simple random samples that are independent. So that are your requirements here. So there must be 2 simple random samples that are independent. And then the other requirements that is on this section 9.1, it says you have to have at least 5 success and 5 failures for each of these 2 samples. So in this case, you have to have 5 plus success for population 1. And you also need to have 5 plus, that means 5 or more, failure in population 1, and you need the 5 plus success in population 2, and then 5 plus failure for population 2. So you have to do, this is the, so the first thing is this 2 simple random sample and independent for this question?
Yes.
Yes. Okay. And the word is the simple random sample is right over here. So that's why it is true in this case. Okay. Next, it needs to be 5 success in population 1 and 5 failure in population 5 plus in population failure. And then, so how do we know if we fulfill the second requirements? Is you look at your X. So if you look at your X in this case, you notice that your X1, so this population success for population 1 is called the X1. In this case, we found out it's 31, and 31 is 5 plus. Now, does anyone know how to figure out the failure one?
Do you subtract
From what?
31 from 20 to 23?
Yep, so you take 28, 23 minus 31. So this number is what we call as your failure rate in population 1. Now, you think that number is more than 5? Yes, right? You do not need to calculate it, but we can tell that number is 2,000 something. So is definitely more than 5. Same thing with you do the second population. For those who wear seatbelts, the 16 people die, so that means that it's a success. And then in order for us to find the failure one, is you also subtract, like what Suli says. We will take the 7,765 and you minus 16 because there are 16 people die. So again, you do not really need to take out your calculator to do this. We know that all these numbers, 31, 16, 2,000 something, 7,000 something, these numbers are 5 plus. So in this case, your second requirements met here. Okay. Since both requirements met, so this requirement is fulfilled. Okay. So so we're gonna do the second step, step, which is to write your hypothesis statements. So in order for you to write your hypothesis statement, again, you can use H0, which is a null hypothesis, H1 or HA, which is an alternative. Now, this is the one that you need to be careful here. So the first one, as you know that the null hypothesis, we always use equal to because your null is always equal. So P1 equals to P2, the first population, the rate or the person who died, the rate, the percentage of those who not wearing seatbelts is the same as the one that wears seatbelts. But the alternative is the one that you need to watch out. So can someone tell me what happens to your alternative if we say seatbelts are effective in reducing fatalities, reducing death in this case?
Is it Lawrence?
Is that Lawrence? I cannot really hear you guys.
I think it's equal to.
Equal, alternative.
Oh, I mean, the statement says equal to, but alternative is going to be not equal to.
So Lawrence says is say not equal to. Anyone?
I think it's less than.
Is that Grace?
Yeah.
So Grace says less than. Lawrence says not equal. So class, as you know that this is important, right? If you write this wrong, everything after that is all going to be wrong. So what is the meaning when I say seatbelts effective in reducing death? If population 1 is not wearing seatbelts and population 2 wears seatbelts, so as you know that this is what a lot of you will see this in your online homework here. So is that this? What does this stand for when you say P1 not equals to P2? This means that if those are the death for those people who do not wear seatbelts. Are you going to use SW for seatbelt? SB for seatbelt is what? You should use the word equal to the death rate or the fatalities rate, those who do wear seatbelts. Is this what the claim statement says?
No.
No. So that means this is wrong. Now, then we will talk about P1 is less than P2, right? So this is where the death rate for those who do not wear seatbelts is less than the death rate to those who do wear seatbelts. So is this the meaning that seatbelts are effective in reducing fatalities? Is this the same as what the claim says?
No.
This is also no. If you write this, it means that people who do not wear seatbelts, the death rate is actually what? Less than those who wear seatbelts. That means that seatbelts in this case is those who wear seatbelts will actually what? Not reduce, is what? Will increase fatality here. This is what if you do this way, because those who wear seatbelts is the people who die from wearing seatbelts is more than those who do not wear seatbelts. This is wrong. So the correct answer in this case is P1 is what? Greater than P2. This is the correct one. This means that those people who do not wear seatbelts, the death is actually higher than those who wear seatbelts, which means seatbelts is reducing. So if you read backwards, P2 in this case is less than P1. So that's the meaning of this. So that's the reason why this is something that is very challenging and is very important. And because if you pick the wrong alternative, you get it wrong. So the correct way for us to write this is P1 is less than P2. Not less than, sorry. P1 is greater than P2. Sorry about that. It's not less, it's greater. So so make sure that what is written down on here has to match with your claim statements. So if this does not match with your claim statements, your statement's gonna be wrong. Questions here? Since this is talking about proportion, the sampling distribution is gonna be normal, in this case, Z. Okay. Now, so now we go to the stat 4. We're gonna need to go to StatCrunch. Okay, so you go to StatCrunch and then you enter this number in. So so StatCrunch. So you go to stats, you go to proportion stat to sample with summary. And the number of success in this case for sample 1, which is this one, is 31. The number of observation in this case is 2,823. Number of success here is 16. For sample 2, the total observation is 7,765. And this is equal and this is greater than. Okay. So it's P1 is greater than P2. So be careful with these kind of questions, as I mentioned. You will see this in your homework. So your test statistic came out to be this, and that's your p-value. So your test statistic in this case is 6.1. And then your p-value in this case is now if you see this in your StatCrunch that your p-value is less than 0.0001, it means it's 0 plus, means that number is so close to 0. Okay, so this is how we do this question. Now do not forget, class, that if, let's say, if you do the wrong statement, means if you change to be less than, look at your, I just want to figure out, I want you guys to know, this is the test statistic and p-value when I use greater than, right? What happens if I use less than? What do you notice? The test statistic is exactly the same, but your p-value is totally opposite. When I say opposite, means like if it's 30%, then this will be 70%. You know what I'm saying? So this, because this is close, so close to 0, and the opposite of 0 is 1. So that's why when you do the less than, you notice that your answer is a little bit different. And what happens if you pick not equal? Because you know, Lawrence pick say it's not equals. And guess what happens when you say not equals? It's kind of the same here. So but I still want to tell you that it's not always the same like this. Because our p-value here is very small, it's 0 plus, so that's why you don't see the difference. However, if this p-value is not 0 plus, let's say it's 10%, let's say your p-value is 0.10, if you put not equals to, that 10% become 5%. Okay, you will see some examples coming up that if I change. So that's the reason why that is very, very important that you pick the correct hypothesis statements. And it's all based on a claim statement. So I want everyone here to do number 5, number 5, which is decision here. And I also want you guys to write your own conclusion. So please do your own here. I want you guys to figure out your own decision and your own conclusion. Yep, go ahead and do this. Because I will ask you guys. All right, let's do decision first. Skylar, can you tell me what is the p-value that you have in this case?
0 plus
Okay, and what is alpha in this case?
0.05.
Okay, very good. Just again the question, right? Skylar, can you tell me, is this p-value is less than or greater than alpha?
Less than alpha.
And what decision we make? Reject or fail to reject H naught?
Reject.
So that is correct. So if your p-value is less than alpha, you will reject your null hypothesis. This is the same thing you guys did in chapter 8. We're going to use back in chapter 9. Now I want you guys to look at your conclusion. Your conclusion, you remember you got four, right? 1, 2, 3, 4. We'll start typing it. So it's either there is or there is not sufficient evidence to support or to warrant rejection. So it's either one of this of the claim that I just copied down the claim statement that seat belts are effective in reducing fatalities. So we just need to pick which one do we need to pick here for this case. Anyone know what conclusion we should draw here?
There's sufficient evidence. There is sufficient evidence to support the claim that seatbelts are effective in reducing fatalities.
There you go. Thank you so much, Casey. That is correct. The reason why we use the word there is because you are rejecting the null hypothesis. We use there is. If you use fail to reject, then we use there is not sufficient evidence. Evidence to support. The reason why we use the word support is because this is the claim statement is talking about inequalities. Doesn't have equal sign. Okay, doesn't have the word equal sign. So that's the reason why that we use the word support. If you have an equal sign or same or is or no difference means equal. We have to use the word warrant rejection. So this is how you pick 1, 2, 3, 4. If you don't want to remember 1, 2, 3, 4, this is how I remember. When you do the rejection, the null hypothesis, we use there is. If you fail to reject, there is not sufficient evidence. To support, in order for you to use the word support, your claim statements has to have no equal sign. If you use the word warrant rejection, then your claim statements must have an equal sign. So that's how you pick the same thing you learned in the 1, 2, 3, 4. This is the correct conclusion. So what does that mean when you write this conclusion? There is sufficient evidence to support the claim that seatbelts are effective in reducing fatality. Is that P1 is equals to P2 or P1 is greater than P2? So if you make this conclusion, is that P1 is equal to P2 or P1 is greater than P2? Which one?
Greater than.
Okay, it's greater than. Another way you can figure out which one you pick is number 5. Since you're rejecting the null hypothesis, if you reject H0, then you will pick H1, and H1 means P1 is greater than P2. So this means P1 is good. The reason why I'm putting this on here is because we're gonna do part B, where we also used to do the test the claim, but this time we use the confidence interval. And as I mentioned early on, the conclusion that you got from part B is going to be the same conclusion as part A, all these things. These two have same conclusion. If you don't get the same conclusion, means something is wrong. Now, in order for you to find the confidence interval in part B, you need to find the confidence level. Okay. How do you find the confidence level? Depends on your claim statements. Depends on your claim statements. If you have a one-sided test, which is the left tail or right tail, your confidence level is 1 minus 2 times alpha. If you have a two-sided test, then your confidence level is 1 minus alpha. So can someone tell me, reading this number 2 here, is this a one-tail test or is it a two-tail test?
It'll be right tail.
Okay, so it's one-tail test. Okay, so this is one-tail test. So one-tail test, in this case is right tail, you're correct, Lawrence. So what is going to be 1 minus alpha or 1 minus 2 alpha?
1 minus 2 alpha.
1 minus 2 times alpha. Yep, this is the correct formula. And can someone tell me what is alpha in this case?
0.05.
So can someone use a calculator to tell me what this is? So that will be 0.9, right? Or in other words, 90% confidence level. So now we need to figure out what is the 90% confidence interval. So in order for us to find a 90% confidence interval, what you need to do here in StatCrunch is you just go option and you choose edit. And these are the same number that we did in number 2A, the testing, but we just need to select perform the confidence interval, and then you change this to a 90% because the confidence level is 90%, and you compute. And this time you will get the lower and the upper limit. Okay, so this is where you will get your lower and upper limits here. So this is the how you get change from hypothesis testing to confidence interval. You just go under option and edit, and you will get, and then you just move to the performing the confidence interval. Change and put in the levels there. So this confidence interval is 0.0056 and 0.0123, okay, something like that. Okay, so the main part of this is what is your conclusion here? So as you know that every time when you do a testing the claim, that means you have to give me your conclusion. So does anyone remember how you make a conclusion if I give you a confidence interval? The conclusions is right on number 3. So if you look at number 3, this is how you make conclusions. For if I give you a confidence interval, if both of the values inside the confidence intervals are negative, then you conclude P1 is less than P2. If both values are positive, you conclude P1 is greater than P2. If both was one negative and one positive, which includes 0, we call it, we conclude P1 is equals to P2. So by looking at your confidence interval that you found here, these two values are what? Are they both positive? Are they both negative? Are they one negative, one positive?
Yeah, both positive.
So if they're both positive, what can you conclude?
P1 is greater than P2.
So the conclusions I just put down here, since the confidence interval values are both positive, so we conclude P1 is greater than P2. And if you look at the conclusion you did in part 6, in part A6 here, is your conclusion match or are they the same?
Match.
Yep, which is a match, which is the same as a conclusion in number 6 here. So it should match. It should be the same. Okay. I think I told you guys before, right? So if this is not the same, I would say you will probably get something wrong. Okay. C, what do you suggest about the effectiveness of seatbelts? What can you tell me about seatbelts here? Do they reduce? I mean, do they save life or do they not save life wearing seatbelts? So in this case, wearing seatbelts, what? Are they reducing death or are they increasing death, or is the same?
They're not reducing death. So how would you put that? Because P1 is, I mean, it just makes people more reckless, right? Not wearing seatbelts.
This is talking about people killed. So your
Oh.
data here is talking about those who died from.
So
wearing
those
it.
who wear seatbelts die more from those who don't?
No. Don't forget the
Dude.
P1. Don't forget P1 stands for what? Those who what? Not wear a seatbelt. So when you do this, means what? Those who do not wear seatbelts die more than those who wear seatbelts. So what can you conclude here?
Oh,
Don't forget yep. Seatbelts, wearing seatbelts, what? Save life, right?
yep.
Oops, sorry, the other. Right. So I think you guys know that. So do wear your seatbelts in your brain. So class, this is what happens when you do population 1, those who not wear seatbelts, right? Population 2 is wear seatbelts. So I want you guys want to do it. I want you to switch these two around. I want you guys to switch these two around. This is your work here. Same questions, but your population 1 now is those who wear seatbelts, and population 2 in this case is those who do not wear seatbelts. Now you're gonna change things around, because sometimes when you do your homework or your test, you can do that. Some people do that, and for that case, I want to see what's the difference here. Okay. So I want you guys to now population 1 are those who wear seatbelts. Again, I use SE for seatbelts, and population 2 is those who do not wear seatbelts. Okay. You do not need to go through the requirement, just ignore the requirements, and I want you to do the rest of it. So we still use this example, the data here. Still the same claim statements. So the requirements, I just check it. Grace, I might need to mute you. 2, I want you to know how to write your hypothesis here. Three is still Z because it's proportion. So this one is no change. And I want you guys to go to your stack crunch and figure out what happens to your test statistic and your p-value. Just so you guys know what's going on. So as a teacher, I know what's going on. I want you guys to know what's going on here. And this is quite important here. And then the decision and the conclusion as usual. Because I want you to compare these two. And then you do the confidence interval. Same thing that we just did. Watch out for your H1. Because if that's wrong, everything is going to be wrong. So be careful with it. Can you do this way too in your test? Yes, you can do the way that I did in here with the Adobe here, and you can also do the one that on the paint, like this one. Yep. Either way, you can do it, but your answer is a little bit different. So that's the reason why when you do your online homework, they tell you which one is population 1, which one is population 2. So you only stick it this way or that way. But in the test, I didn't tell you which one is first population, which one is second population. You can do it this way or that way, but your answer is a little bit off, but your conclusion is still the same. So this is still P1 equals to P2, your null hypothesis. P1 equals to P2 is always equal. Anyone wants to do the first an alternative hypothesis, H1 or HA? P1 is what here? Anyone? Grace?
Is it less than?
Yes, this is correct. Okay, so if you put the first population that wear seatbelts and population 2 do not wear seatbelts, and the claim statement says that seatbelts reduce death, that means those who wear seatbelts, the people die is less than those who do not wear seatbelts. So that's why that means seatbelts will reduce the death. So this is the correct way to do if you put population 1 as seatbelts, population 2 is those who do not wear seatbelts. Yep, Grace, that is correct. So you can use this way, but make sure your population 2 is switched around like what we did here.
Can you explain that a little bit further to me? Because it's saying, the test claim is saying that seatbelts are effective in reducing fatalities. Okay, I understand that part, right? But if you're switching around to P1 is wearing seatbelts now, wouldn't that still be greater than P2 since it's saying seatbelts are effective?
Effective means they are good.
Yeah.
So
So,
those,
I mean, yeah.
so
So
this,
would it still be?
these are those people who are deaf, those who wear seatbelts. And these are those deaf who do not wear seatbelts. I'm talking about deaf here.
Oh, okay. I keep getting
Because
stuck on the whole seatbelt thing and not the death thing.
The reason why is because your question is giving us those who got killed,
Yeah.
not those who were not killed. You know what I'm saying?
Yeah.
So if you,
Okay.
so that's why it's based on the question, So those are, so since the data give us those who got killed, so that means the death rate for those who wear seatbelts is going to be less than those who are not wearing seatbelts, means the seatbelts are reducing.
So wait, are we saying that the people who wear seatbelts, 31, are still killed?
They are killed, yes. This is in the question here.
But then 31 wearing seatbelt.
No, 31 were killed, those who are not wearing seatbelts.
No, like I'm talking about right now that we switched the question. So we're saying P1 is people who wear seatbelts, right?
Mhm.
So does that mean 31 is killed of people who wear seatbelts?
No. Again, the same question. How many people got killed wearing seatbelts?
16.
16, yeah. So this X1 in this case will be 16.
Okay, so what's the difference in what we did before and what we're doing now?
Your inequality is different.
So yeah, so what makes, how did it become less than?
Well, because this is mean those who wear seatbelts is the death rate is less than those who do not wear seatbelts.
Is that what the claim statement is saying?
Yeah, it says seatbelts save reduce fatalities.
Because we used the same claim statement for the first one and it was greater than.
Because P1 is those who do not wear seatbelts. So you
Yeah,
guys, okay, you
understood what we
you
did
guys know
before.
what's going on when so if I give you something like this, how do you read this?
So
3,
is greater than 2.
but if I switch it around, what do you say?
2 is less than 3.
So what I'm talking about here is this fellow here is greater than, where this is those who do not wear seatbelts.
So in other words, we're just gonna flip, if we did it correctly the first time, and then you want us to do this again, we're just gonna flip the whatever sign it is from the opposite,
Yeah.
right? Okay.
Yeah, you have to read, you have to understand this. Don't forget, this is all talking about the death. This is talking about death rate, those who not wear seatbelts. You know what I'm talking about? And these are the death rate. That means how many, there are more. So when you say this, means what? More people die,
Mm-hmm.
do not wear seatbelts, right?
Yes,
Compared to those who wear seatbelts, right?
right.
Does that mean seatbelts reduce death?
Mm.
When I say those who didn't wear seatbelts, more people die compared to those who didn't wear seatbelts?
Yes,
Yes. And how about this? If I switch around, this is those that the death rate of those who people wear seatbelts is what?
less.
Less than those who do not wear seatbelts, right?
Mm-hmm.
Is that the same thing as seatbelts reduce death?
Yeah, I think so.
Yep. Yes. And you will see what's happening to your test statistics and p-value. That's why I want you to try this, because your answer is a little bit different, but your conclusion is the same. So when you do your test statistic, what do you do with StatCrunch? These two numbers, these two samples are what? Switch around, right?
Yeah.
So in this case, this is 16 now. And this is 7765. And then this one are those who do not wear seatbelts. How many people die here? 31 die. And 2,823 out of this many people. And now we switch, so this one also switch around. So when you hit compute, what do you guys see here? What change?
The Z star.
Your test statistic used to be what? Positive.
Mhm.
Now what happens to your test statistic? It becomes negative, and it's exactly the same, right? Negative 6.106. But your p-value is still what? 0 plus. Okay. So what happens here, class, is for this way, because you say, because we switch around, so your less than, so it's a left tilt test. That's why this test statistic will be in a negative form. And this area is still very small, 0 plus. That's what we call p-value. If you go to this one, the other one, the original one that we did, because you use greater than, so this is what happened is that now your greater than means it's a right tilt test. This will be your test statistic, as this is on the right side, because this is 0, right? So it should be 6, it'll be on the right side. And this probability or this p-value is still 0 plus. So that's what happens to this way, is it is on the other side because we use greater than. But no matter what you use, your decision is still going to be the same, because your p-value in this case is what? Less than alpha. We will still rejecting the null hypothesis.
So that doesn't affect the confidential.
Oh yeah, it will. Mhm.
It will, right?
Oh, yes.
What I was thinking.
That's the reason why that when you're doing your test, you can do it both ways. Your answer is a little bit off, but your conclusion is still going to be the same. Okay. Can someone tell me what is your conclusion you're going to make if you do in this way? It is still the same conclusion, right?
Yeah, reject.
There is the same conclusion, right? Because you reject and it doesn't have equality, right? Because this also doesn't have equality. So the conclusion is still same, saying that P1 in this case is less than P2. Don't forget, we use P1 less than P2 here, which is there is sufficient evidence to support the claim that seatbelts are effective in reducing fatalities, which is P1 in this case is less than P2. Yes, this is the same thing here. So what is different compared to this? The only difference you see is your test statistic. It goes from positive to negative. And don't forget, your alternative hypothesis will be changed from greater than to become less than. Okay. Now let's talk about your confidence interval. Now we are still using a 90% confidence interval here. The reason why is because we're still using 1 minus 2 alpha. It's a one-tailed test. And alpha in this case is 5%. So 1 minus 10% is 90%. So if you look at this, I'm going to change this. Now I'm going to change this to 90% using, what can you tell me with this confidence interval and the confidence interval that you found earlier on here? What can you tell me?
They're both negative.
And what happens? Yep, they're both negative. And
They equal each other. It would be
compare this confidence interval and the confidence
never mind.
interval that
Sorry.
you found on here. What is
P1
the
is still greater than P2.
So the conclusion here in this case, because both of these are negative, right?
Yeah,
So in this case, P1 is what?
still greater than B.
No,
Still less
less
than,
than
sorry,
P2.
less than. Less
Which
than.
is the same as this one, right? But what I
Yeah.
want to point out here, class, is look at this confidence interval and look at this confidence interval. What do you see?
The numbers are switched around.
The numbers are switched around, and what else?
Or negatives.
Then the sign switch. Is that one of your property that we talk about that on Wednesday? Up here in the property, if you remember number 4. What did I say if I say if you switch your population around, what happens? Remember that?
Switch.
If it's positive, it will come negative, and if it's
The-
negative, it will be
Yep.
positive.
So the sign change switch, right? That's what Grace says. From positive to negative, and negative, and what else also? And the lower upper will also what?
Become
Will be
upper and the upper will become lower.
Yes, 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 that's correct. So your upper lower become lower upper. So this is the same thing we just did here, right? Our lower become what? Upper, and our upper become what?
Low.
Lower, and they are both positive. The sign will become both negative. So this is something that something different. But however, no matter what you do, the conclusion that you make here and the conclusion that you make here, they are what? They are the same. And that means that what? Seatbelt save life, right? Because those who wear seatbelts, the death rate is actually what? Less than those who do not wear seatbelts. So no matter what, as I say, if you switch these two around, your hypothesis H1 will be different. Your test statistic will be from positive to negative, is different, and you find out that your confidence interval will be also a little bit different, but your conclusion, everything is going to be the same. That means in this case, seatbelts will save life. You guys got what I'm trying to show it to you now? You guys got this? And that's the reason why I'm showing you this is because in your task, you can do it this way, and you can also do it this way. But you have to declare to me which is the first population and which is the second population. Because if you declare this way, then you have to do this way. If you declare this way, then your answer will be, you will have to do this way. Questions you guys have? So you know being a teacher is not easy, right? Because I have to know all this. And now I'm teaching you guys that when I grade your test, I wouldn't do 2, I just do 1. And if someone flip this around, then I know that your test state will be flipped around, and your confidence interval will be switch around too. And you still get correct. If you do this way, you still get all the whole points. Everything is correct. And the same thing happens on here. If you do it this way, everything is correct. Yep. Questions you guys have with me?
Yeah, I have a question. So if you're saying that either way is correct, like which answer is like the real correct one? I'm just curious.
For me, I'm looking at your conclusion.
Oh, okay. So you're not.
I will look at your numbers and stuff, but your conclusion is the main part of it. The
Okay.
main, and this conclusion is the same. Means life, wearing seatbelts save life, or wearing seatbelts reduce infantilities. You guys all right here? Okay. So that's why I'm not picky how you do it, but make sure you guys know that. But for your online homework, they already tell you which one is first and which one is second population. So they say this, then you have to do this way. You cannot do this way. You know what I mean? Because majority of your online homework, they will tell you which is the first population and which is the second population. A bit more flexible for me. Questions in this one, anyone? Again, this homework is due on Wednesday. So you got only one homework due on this coming Wednesday, the 17th, which is 9-1. Only 10 questions. Okay. So this section is all about population proportion. So this is where they talk about proportion, categorical. So if you wear seatbelts, how many people die? If you don't wear seatbelts, how many people not die? You know, this one is talking about LA and New York shooting target. Now talking about proportions means what's the rate, percentage, proportion. They're all the same. So so the next one that we talk about is 9.2, where we do the mean, 2 means. So we got 2 proportion and 2 means. Now the 2 means is special because in 2 means we got the independent samples and we also got dependent samples. So the independent samples that you see here is used in 9.2, and the dependent sample is used for in 9.3. So when you go to 9.3, this is also talking about mean, but they're also talking about mean, but this is dependent or matched pair, sometimes we call. So a lot of students get confused between these two, and they got it wrong in my test. Okay, so be careful with this. So when the test is a little bit different compared to 9.2 and 9.3. So how do you know which one is 9.2 and which one is 9.3? What is independent means and what is dependent means? So let's talk about that now. So if 2 samples are independent, means that one population is not related to another population. Okay, so this is what we call as independent, means one population is not related to another population. Let's say that you got 2 groups. If they are independent, means this group has nothing to do with the other group. For example, male and female. So if I break this group into male and female, the class into male and female, this is called independent, means that you can either be male or female. Okay. Another example is like if I break you guys based on age group. Okay, so either you are young or you're old, right? So so this is called in these two groups. So if you are 21 and below, you go to this group. Above 21, you go to that 21. Yeah. So I can break you into these two groups. This is called independent groups. Or if I break you guys based on location, like what state you're from. Okay, so since we are from Minnesota, so it's not fun. So if I want to study to Minnesota and Iowa, or Minnesota with Illinois or Wisconsin or whatever state we want. If we got two different states, this is also what we call as an independent samples, because you either belongs to this state or that state. You cannot belong to both. Okay, so this is what we call as an independent samples. Okay, what is a depending samples? A depending samples, sometimes we call it the match pair. The match pair is where one sample is somewhat same or match based on their relationship. Okay, or sometimes a value that consists of a measurement from the same subject. Example is like before and after. Okay, so this is what we call as a depending samples in this case, or match pair. Is example is before and after, like weight loss. Okay, so that means one person or one subject has to give me two measurements. One is before and one is after. Example in this case will be like weight loss. Weight loss in this case means that means you want to go weight loss, you measure your weight before you do your before you do your diet and exercise, and then after that, after 3 months, you do all your diets and exercise. We do it, after those things, and then you see you got a weight loss. So that is considered dependent. So anything that you weigh or you measure before and after, like testing, okay, we want to see if tutor, you pay tutoring, right? Private tutoring is expensive. We want to see if tutoring is really going to help your test score. So what we do is, before tutoring, you take a test. Then after you get all your tutoring, you pay all this, and you take another test and see if, there's any changes. So that is what we call as our dependent samples. Also, another type of dependent sample is based on relationship, like husband, wife, brother and sisters, something like that. So because we match them based on they have a relationship somehow, because you know each other for so long. So so that is also called as depending. So husband and wife, sisters and brothers, so those kind of things is what we call it also match pair. So it's same as dependent in this case. So if you have such case in your questions, we will put this in 9.3. Okay, so that's how you figure out which one is 9.1, which one is 9.2, and which one is 9.3, and they're all talking about means. So both of them are talking about mean here. So be careful with this. Okay, and the way that we write this two are totally different. The way that we perform the testing is very different. Okay, so I got students flip these two around in the test, and guess what happens? They lost a lot of points because they do completely different ones. Okay, so we have some notation here for this. Is again 9.2 is all about this. Mu1 in this case is for population mean. So this is a population mean for the first population. Okay. Sigma in this case is the population standard deviation for the population 1. So again, class, anything you see 1 there means it's for the first population. This is sample size, and 1 is sample size for the population 1. Okay. Now the X1 bar that you see here is called the sample mean for the population 1. And then S1 in this case is the sample standard deviation for population 1. And you can change all the one subscript to become 22222, means it's the same thing, but it's for population 2 in this case. Okay, so these are little notations here. The requirements. The first requirement says that the sigma 1 and sigma 2 are unknown, and we do not assume they are equal. So this is default. So when I say default, means you do not need to check it. Okay, so you should, this is always is given. I mean, that means this fix is always given to us. It's no change. It's always the same as this. So we always assume that sigma 1, the population standard deviation for the population 1 and population 2 is not known to us, and we assume that these two are not equal, not the same. Okay, so you do not need to check this. What you need to check actually number 2, 3, and 4. Make sure these two samples are independent. So again, independent means one population does not related to another population. They must be simple random sample, and it has to be a large. Your sample size has to be large, or your population has to be normally distributed. If you have a small samples, make sure that you're checking for no outliers. So if you don't have more than 30 samples, you can still use this as long as your sample size doesn't show any your sample doesn't show any outliers in this case. So you have to draw a box plot here. Okay, so box plot will be the one that you draw. Okay, so you do this, please don't use this formula. But if you do help me to solve this, yes, all this icky formula you see here, they will not, so do not need to worry about all this. So all the formulas see here is not important. What is important, class, is how we write your hypothesis statements. So remember last time how we write your hypothesis statement is we use P1 and P2, and this is equals, and then this is less than, greater than, or not equals to. So in this case, we don't use P because P stands for proportion. So we will use mu here. So it's mu1 equals to mu2, or the alternative in this case is H1 is mu1 is either less than, greater than, or not equals to mu2. Okay. So it's very similar to what you did in 9.1. Instead of using P, we use mu here, stands for population mean, instead of proportion here. Okay. And there is also another way to write this, your StatCrunch. Instead of doing mu1 equals to mu2, if you subtract mu2 on both sides, it will be written down as mu1 minus mu2 equals to 0. Okay, so this is the same as the other way. So I'm not very, again, same thing with proportion, right, that I showed you last time. I'm not very picky which way you write. Make sure that if you write one way, do the other way. Don't, so follow one way. So you can do this way or this way, up to you. Mu1 minus 2 equals to 0. We should use this way, but I think your online homework, when you do your StatCrunch, is using this way. They are the same. Okay. Questions with this? How do we, Casey?
Yeah.
Okay. How do we use StatCrunch for this? We will do StatCrunch, T-stat2 sample. So we do a lot of 2 samples here. One with data and one with summary. So again, what is data? Data means the question provides you the data, or if it's in your homework, it's important. If you import anything in StatCrunch, or if you use those data from the textbook, the bears, the weight, and all those things that you got it from the StatCrunch, you use with data. If you use with summary, means summary statistics provide to you, means the question provide you the sample mean, the sample standard deviation, the sample size, and so on, so on. So you do with summary here. Okay. This chapter 9.2 is going to be the same as 9.1, means you have to perform both the hypothesis testing and finding the confidence interval. So this is the same as what we did in 9.1. So in this case, every single questions you did here, you have to follow 9.1. Okay, that means we do both things. And if you remember 9.1, we have a lot of other rules like the first, remember the when you interpret confidence interval, if they're both negative, both positive, or one negative, one positive, this still applies in 9.2. Okay, so this rule that you got here will be applied in 9.2 also. Okay, and remember the population, when you switch around, your sign switch, your lower upper also switch. This also will be applied to 9.2. So that's why if you know 9.1, 9.2 is almost the same, but instead of using P, we will replace by mu. Okay, you just need to replace mu1 and mu2. Instead of using P1 and P2, 9.2, you will replace it with mu1 and mu2. That's the only difference between. So it's very similar. And the another thing that's different is your sampling distribution. So because in this case, I told you proportion, we always use Z. So in this case, we are mean. So your sampling distribution in this case is going to be T here. Okay. So so a little bit difference, but not a lot of difference. Questions you guys have? All right, let's take a look at the first two questions. This first two questions is asking us, are they independent samples or are they dependent samples? Remember, are they independent or are they dependent? So independent means one population not related to other. The dependent means they are matched or before and after. So let's read the first question here. So to test the effectiveness of Atkins diets, 36 randomly selected subjects will wait before the diet and then 6 months after the treatments with the diet. So they wait after. So the two sample consists of before and after weight. So is this an independent samples or this is a dependent sample?
It's a dependent sample.
So this is a dependent sample. Yep. So you will need 9.3 here. Okay. So next section. How about question 2? Annual incomes are obtained from a random sample of 1,200 residents in Alaska and then another 1,200 random samples from Hawaii. Is this a dependent or is that an independent samples?
Independent samples.
So this is an independent samples where you have to use this section 9.2 to do this kind of work. Okay. Questions with this? Very basic, but very important. Okay. And don't switch these two around. You get in trouble. Now let's talk about question 3. If the heights of men and women are used to construct a 95% confidence interval, we find that this is given us by 11.61 centimeter is less than mu1 minus mu2, it's less than 17.32 centimeters, where population 1 in this case is men height and population 2 is women's height. So question A, this is what I like to ask in my finals also, especially multiple choice. Can you tell me what is the confidence interval for the heights if I switch around? Means your first population is women now, and your second population is men. So what happens to this confidence interval? Does someone tell me the numbers?
Do they just flip and then turn negative?
So what you get?
Negative 17.32. And then all that.
Yep. So I'm going to use mu W minus mu M because sometimes it's very tricky to see what is 1 and 2. So W means women, M is men. Yep. So sometimes you see me writing this a lot so that I don't want to use 1 and 2 because then you just ask me what is 1, what is 2, men, women, you know what I'm saying? So I'm just use U, W and mu M. W for this case is women, M is men. And then what next, Armin?
Negative 11.61.
Yep. And don't forget, because last time we used proportion, proportion has no units. This time we use mean, mean has units. Okay, yep, that is correct. Question B, what do these confidence intervals suggest about the heights of men's and women's? So let's talk about this 11.61 and 17.32. So this question is, yep.
See, I thought that I get that it flips, but do we not change it from like the signs at all?
No. Every time when you do a confidence interval, the sign is always less. And this number is always, the left-hand side number is always smaller than the right-hand side. Right, this
Oh,
is a
good.
lower and upper, yep. Suli?
I'm just wondering, I guess it's new women minus new men.
Yeah. This is mu women minus mu men, yep.
How come we didn't do 2 and 1?
Because it's very confusing. I can use 2 and 1, but I recommend use WM because if I use this, that it will be mu1 and mu2, and then you get confused. Well, this is also mu1 and mu2, right? But this one in this case is simple for what? For women. So that's why sometimes I do not want to put 1 and 2. Sometimes I use women and men, so that, or W and M, to just so you know which one is which.
Okay.
So it's the same thing, but I recommend use W and M than 1 and 2 sometimes because it's more. This is what happens when you take more higher level statistics class. We stop using 1 and 2 here. We start labeling them with W, M, something like that. All right, so looking at this confidence interval, what kind of conclusions can you do? This is part B, is asking for conclusion. So again, the conclusion is same as the conclusion you learned in 9.1. Are they both negative? Are they both positive? Or are they one negative, one positive? So which one we get for here? If you look at the original one, I'm not talking about I'm talking about this original one.
Positive.
So what happens if both are positive? Both positive values, what can you tell me?
P1 is greater than P2,
Now, only different here is we don't use P, we use what?
men and women.
Mu1 is greater than mu2. And again, because you know which is one in this case is what, man or woman?
Man.
Yeah, man. Okay, so that's why sometimes I really we use M and W instead of 1 and 2 so that you can see more clearly that 1 in this case is man and 2 is women.
So
You guys all right?
with
Yep.
B, do you automatically assume that it's talking about whatever number 3 is asking? You're not going to use A?
Because your A might be wrong. Right? So yeah, we
Yeah.
always use what we have is in the question because the A answer might be wrong.
Yeah. No, well, what I'm asking is we're just not going to assume anything. We're always going to go back
Based on the
to whatever
question.
it's asked.
Yep.
Okay.
So if I do A, B, C, D, E, they're all going to be based on what? This question.
Yeah. Okay.
Until I say refer to part A, then yeah, then we look at the part. Yeah. Questions? Next, question 4. Now we're gonna do a bit more. Now, if you see this in my test, I say assume that the 2 samples are independent, are normally distributed, and the population is standard are equal. This means that your requirements, you do not need to check your requirements. Okay, so if I have that in your test or in your homework, that means automatic. The requirements are checked here. Okay, so this one I highlight in green is telling us that this requirement that I see here, 1, 2, 3, 4, is all fulfilled. So that means you can skip it. You guys all right?
If you compare B to the original question, it seems like the women are.
No, 1 is men.
Because we said mu men is greater than mu women.
Because we're using this one.
Yeah.
And 1 is men.
So it's even 17.32 is women, right?
No. This is the difference.
Oh, okay.
The difference. That means that what do I do is I take man's group and I take women's group. I find the difference. And if your difference are positive, means the first population is higher, stronger, more than second population.
Okay.
That's the meaning of it. And if it's both negative, means the first one is less than or smaller or shorter or than the second. Okay. So read these questions. They do have a statement here, claim statement. They always have a claim statement, same thing in your task. So I want you guys to read the questions and find where is your claim statement. Anyone find the claim statements?
Pre-1964 quotas have a mean weight that is greater than the year.
The post. Okay. And as usual, you need to tell me which one is your population 1 and which one is your population 2, because we did an example before, right? If you switch things around, your answer is going to be a little bit different. So can someone tell me population 1 in this case is a pre-1964 quotas or the post-1964 quotas?
Pre.
Okay. And this is post. Can you switch these two around?
Yes.
Yes. But if you switch these two around, then your answer is going to be the same, but your test statistic, your confidence interval is a little bit off. Okay. First thing is the requirement check. But since they give us the assumptions above, the one that I highlight above, so this one is already met or fulfilled, so you don't have to worry about this. So now we need to do your now and your alternative hypothesis. So can someone tell me how you write your hypothesis statements here? That the pre is greater than the post.
Wouldn't it be U1 equals U2?
So don't forget, now is always equal to, and what is your alternative?
U1 is greater than U2.
Yep, because that means your pre-quarters, pre-96 is way more than the post. Yep, that's good. The third one is the sampling distribution. So since this is all talking about mean, you can see a lot of mean here, right? Mean. Do you see any proportion or percentage here? You don't. Okay, so that's how you know that this is talking about mean, not proportion. So for all the mean, the sampling distribution is always T. Okay. So next is the StatCrunch. So now, since we got two choices, right? Is this gonna be with data or with summary?
With summary.
Okay, so this is going to be with summary because the question provides us the mean, the median, and the mean, the standard deviation, and so on. So this is with summary. So you go to your StatCrunch, you go to your stats, you go to your T-stats. Now we do two samples with summary. Okay. So last time is proportion stats. Now it's stats, T-stats. So T-stats, two sample with summary. So what is the mean for the sample 1 here? You cannot round this number.
6.19267.
So again, no rounding. Standard deviation?
0.08700.
And the sample size?
40.
How many? 40 quarters. And how about the second one, the post? The median.
5.63930.
Standard deviation.
0.06194.
And sample size
40.
40. Okay. So in this case, leave this off. Don't put variance. Not the default one. So don't put the variance. Just leave it off. And we want to be mu1 is equal to mu2, and mu1 is greater than mu2, right? Because your sum, your statement says that. So we compute. So so this is your test statistic in this case. So your test statistic is what? 30 something. It's pretty big. So test statistic is 32.77. And your p-value is what here?
0 plus.
Is 0 plus. Now I want you guys to again do your own decision and do your own conclusion. You can write your right, not the own but correct one. So figure out your decision and conclusion based on the p-value and the test statistic that we have here. So you can tell they're using mu here, not p.
We reject, right?
So your p-value is what, less than or greater than alpha?
Less.
So what happens if p-value is less than alpha? We reject the null hypothesis, right?
Mhm.
So what is your conclusion here? There is or there is not sufficient evidence.
There is.
Okay, so because you're rejecting the null hypothesis, there is sufficient evidence to support or to warrant reject. Look at your claim statements here. Do they have equal or no equal?
Isn't it warrant reject? Evidence to warrant rejection of the claim?
Equal, you do warrant rejection. Do we have equal sign for your claim statements?
Oh, no. You know, when it comes to that, are we, because I always get stuck on the HO because that's always an equal. But
Again, yeah. Don't look at HO, look at the claim statement.
Okay.
The one that I highlight in green here. See that? That is the one you're looking for. Don't look at it. Okay. So this is the one, the claim statement is the main part of it. So there is sufficient evidence to support the claim that pre-1964 quarters, the one that I again highlight in green there, have a mean weight that is greater, just copy and paste, than the mean weight of post quarters. Post 1964.
I have a question. So every time when it comes to like equal, I don't have an issue with trying to figure out, you know, like what the conclusions, but every time when we have it where it's like either greater than or less than, I always get stuck. And I don't know why, because it doesn't make sense to me when I read it out loud, the p-value.
So when you say reject means you reject him, reject the null hypothesis. So you're rejecting mu1 equals to mu2 means you're taking him. You're taking H1, the alternative. You're rejecting this fellow. So if you reject this, then you have to take H1. And what does H1 say? H1 say mu1 is greater than mu2, which is the same as what you claim, your claim statement says, right? So that means you're supporting your claim in this case.
Okay, I always got the p-value and then whether it's greater than or less than, equal or whatever to alpha. I always get that part. Every time I do the homework, I always get that part mixed up because I'm constantly thinking that it's
That-
like the opposite.
Again, no, not related at all.
Okay.
They're two independent stuff. So don't put them related. So since this is a one-tailed test because it's greater than, so your confidence level in this case is 1 minus alpha or 1 minus 2 times alpha. This question B, you had to figure out your confidence interval. This will be 1 minus
One tail test.
One tail
minus two
test.
alpha.
1 minus 2 alpha. Yep. So this is a one-tailed test. And don't forget, two-tailed test is 1 minus alpha. So 1 minus alpha is 2 tail. 1 minus 2 alpha is 1 tail. It's as similar as what you did in that one. Okay. What is alpha in this case? 0.05, which is what? Again, is 90%. So if you find a 90% confidence interval, so how do we do this? Is you go to your option, go to your edits, and then now you just change from hypothesis to confidence interval, and you put a 90%. And when you compute, this time the results will give you the lower and upper. So this case, it will give us 0.5252 and 0.5815. Okay, and don't forget the units, they are all in grams. So watch out for units because when we do means we have units. Can someone tell me what can you conclude if you get this kind of confidence interval?
Because they are both positive, then it didn't mean that one is greater than the other. As mu1 is greater than mu2.
Yep. Since both values are positive, mu1 is greater than mu2. Is that the same conclusion as what you made in the hypothesis statement? Is this to the same conclusion? In this case, yes. Okay, so remember when you say this, you're supporting the claim, and the claim says what? That mu1 in this case, the pre in this case is heavier than post. And the last one, question C is asking, do post appear to be weight less than pre? So they always like to do that in your homework. They always like to switch them around. So in this case, we say that the pre is heavier than post, right? Because pre is great, the weight for the pre is greater than. So what they ask for question C is they switch around. Is post weight less than the pre 1964? The answer in this case is yes. So they kind of switch these two around. Okay. So sometimes your online homework likes to do that. So that means instead of you reading pre and then post, they flip it around. And in this case, yes, if you read backwards, mu2 is less than mu1. Mu2 in this case is your post. Your post in this case is less than your pre. So if this happens, why vending machines is why vending machine are not affect very much on it. The reason why the vending machine does not affect the difference here, because it is not significant difference. So what I'm talking about in this case is, when you use your vending machine, you put quarters in there, right? As you know that your vending machine's quarters is all based on how heavy the weight of the quarters. So as you know, we found out that if you put a pre 96 quarters and a post 96 quarters, the weight is actually different. But why vending machines still able to take the pre and the post quarters? The reason why is because that if you look at the difference, is only a 0.5 grams. Do you know how heavy is 0.5 grams? Do you know how heavy is 0.5 grams? Is that heavy or not heavy?
It's not heavy.
It's not heavy. It's like a paperclip. Okay, so 0.5 gram is like a paperclip. So that's the reason why that your vending machine can still accept both pre and post quarters. Is because the difference is just that's just like a paperclip. So that's why they will still able to take it. So that's why I say difference is not significant. That means it's not very huge difference. It's very small different, and that's why your vending machine can still able to take it. So a lot of people try to cheat. So what they do is they attach paper clips into your fake coins, so that the vending machine can take that fake coins because of the weight difference. Yeah, I'm not talking about that now. So because otherwise you guys are all going to be put paper clips in your fake coins. Yeah, we can do that actually, but I'm not telling you that. So so this is the reason why that your vending machine can still able to take your coins here, although they have a although you figure out they are both have different weights. I'm going to take attendance here. So some of you already putting present here. So go ahead and put attendance there. This is the end of today's class. Again, on Wednesday, we will be doing Zoom class, in class. We're going to be doing back on Wednesday, going back to in class, BHCC 108. But if you cannot come to the classroom, BHCC 108, then I would recommend you to join the Zoom, which is the same link as this link. It's a little bit different for that case. It's still the same stuff, but it's hard for me to talk to you guys during the Zoom session actually. So please, if you can come to class, come to class. Otherwise, I'll see you in Zoom. Anyone any questions for me? If you have no questions, you may leave. If you have questions, please stay and I will help you. Yep, don't forget your attendance. Question, Grace?
I do have a question. On the homework, on the first question.
On 9.1?
Yeah.
Uh-huh.
Sorry.
You're fine. What is the question on 9.1? Yep.
Yeah, so they're asking for
The pool, I think.
like,
Oh, this one.
no,
This one? The requirements?
no, wait, let me, is it, oh, no, sorry, the number 2.
Number 2. Give me a second. Sorry. This
That
one?
one.
Yep.
Mhm.
So they were asking, so they you had to read this and they will ask you what is N1, what is N2, what is P1 and P1 bar pet and Q. So so how do you find N1 in this case?
Yeah, so I know that N1 is the sample size.
For
So it
the
will be
first.
197, right? That one.
So this is a trial. This many people are randomized into 2 groups. So one is given a vaccine for the certain disease and the other one is given a placebo. Consider the vaccine group as the first sample. So how many people give in the vaccine?
33?
No. How many? N1 is the sample size. How many people get
Yeah,
the
so
vaccine?
it's 197. Yeah.
So this is the N1.
Yeah. And then
Okay.
P1.
P1. How do you find P? What is P stands for?
Is it
Proportion, right?
Yeah.
So out of this many people got vaccine, how many got the disease?
33.
So what proportion is that?
What do you mean? The first?
For example, it's like I got 33 females. out of this so many, what is the proportion of females in this?
33 out of
What is proportion stands for? If I say,
the population.
if I say that I got 10 girls in my class, and I got 30 students in this class, what is the proportion? I got 10 girls and 30 students. What is the proportion of girls in this class?
10.
No, proportion is decimals.
Oh. So
How you find this?
wait, I got confused now.
If I ask, I got this classroom, I got 10 girls, and then I got 30 students in this case. 30
Is it
students is,
0.1?
hmm?
Is it 0.1?
No. Is the 10 girls divided by what?
30?
30.
Okay.
Mhm. So what is your proportion here?
Wait, so 10 divided by 30.
Yeah, these are decimals, right? That is your answer here. Whatever you got your calculator, that's your answer. But this is not 10 over 30. This is what over what?
It's 187. 10. Is it the 197 over 33?
No.
33 over 197, sorry.
So it's 33 over by 197,114. Don't forget all these numbers.
Yeah.
Mhm. Then you had to round your answer in 8 decimal place. Yes.
8.
So I just put it down here as 33. You have to use your calculator over by 197,114.
Oh, you can put it like that?
No, you cannot.
Oh, okay.
You need to use your calculator.
Okay. So it's 0.0000167.
How many zeros?
4.
You need to be 8 decimal place.
5, 6, 7, 8. So it's 0.0001674.
That is
Yeah.
1, 2, 3, 4, 5, 6, 7. You got only 7 decimal place here.
Oh, 2. 2.
2.
There's 2 next to the 4.
And what's next after 2?
I don't have more numbers.
No more?
Wait, I didn't quickly on the phone. Let me just do it on the calculator. 197. So in the calculator, I have one. Well, it's
1674. Yeah, this is correct. Yep.
Yeah, it's the same. Yeah.
Yep, this is correct. How do you find Q?
That is what I did not understand.
What is Q stands for?
Quartile, is it?
No.
Oh,
What's Q stands for?
sorry. Sample failure.
Mm-hmm. So if this is success, can you tell me what is a failure? Like if I say, so I use my calculator and figure this one out, right? And let's say this is 0.4. This is your p hat, right? Can you tell me what is q hat in this case?
First population, it's
If this is 0.4.
Can I see the example again, please?
Right here. Okay, Eunice.
I am not seeing it.
You're not seeing it.
No.
So this means if you add these two up, you should get what? If you add your P and the Q, what you get? you will get exactly
1.
1. So if I say 30% is female, then how many percent is not female? 30 at minus 100 minus 30 is 70%.
Uh-huh.
So in this case, how do you find Q1?
Mm,
Again, what do I say, Grace? This 2 has to add up to become what?
1
1. So how do you find this?
by adding um
We did this before. Grace, I say 20% is female. Can you tell me what percent is not female?
80
How do you get 80?
because I don't know.
How do you get 80? If I said 20% is female, how do you get 80? You take what minus 20? 100 minus 20, right?
Yeah.
So this is not percent, this is decimal. So what you do, you take 1 minus this.
Oh, okay.
Take this, subtract by 1, you get your answer for Q1.
I got negative 0.9.
Cannot be negative because this is
So 0. Basic 999. 1, 2, 3, 4, 5, 6, 7, 8. So 0.9999834.
how many nines? 4 nines?
Yeah.
I see 3 lines.
Sorry. There's a lot of noise in my house.
I know. Go to your room. So yeah, so you do this. This is your answer. You take out your negative, and that's your answer.
Okay. Yeah.
And repeat again for the second one.
Okay. Yeah, I'll do it.
And then, so that's how you do your N2, P2, and Q2 bar, right? So that's how you get the N2, the P2, and Q2 is you're talking about this many people.
Okay. Yeah.
And then to find the P bar and the Q bar, you have to use the formula. The formula is in the notes, which is right over here. So this is the formula you use. See this formula that this is 9.1, right? So the P bar, this is the formula for P bar.
Okay.
You take how many people got the disease. So you got 33 people got the disease, and also what 108 people got the disease, right? So you add this up and then divide it by the total, which is almost 400,000.
Okay.
That is your P bar.
Okay.
Now, once you find your P bar, how do you find your Q bar? Like what we did just now, 1 minus it.
Okay. Q bar.
Yeah. So don't forget, if you know P, you should know Q because you just take 1 minus the P.
Okay.
And that's how you do all these questions here.
Okay.
Make sure, watch your rounding, watch your rounding.
Yeah.
This is
Thank
the one
you.
that you need to brush up. Okay?
Yeah. Thank you so much.
Okay. All right. I'll see you on Wednesday.
Okay. Thank you. Bye.